Components in electrical circuits can be wired up either in series or in parallel. The easiest one of those two is in series, but there's certainly lots of issues with it. If it's wired up in series, it means that all of the components are in sequence, wired up one after the other. So here's an example here where we've got two globes wired up in series, one after the other. Now, one of the issues with that is that if you have to have them both on or both off. It's either just on or off, and that's it. You can't have one on but not the other. What happens if one blows? The whole circuit fails. It's just like a switch. So if that element blows, then we've broken that circuit and the other one won't work either. Another issue is what we call voltage drop, because each of the components in the circuit take electricity, take voltage. So say for example, if we've got a 6-volt circuit, 3 volts are going to be taken by that one and 3 volts are going to be taken by that one. But what would happen if we had a series circuit where we've got 3 globes? Now we've still only got a 6-volt power supply, so what would be the voltage there for each of these globes? 2 volts, 2 volts, 2 volts. So we start adding more components and each of them gets less of the share of the voltage, and so that they're dimmer. This is what we call voltage drop, and it's another issue of series circuits. Parallel circuits are far more common in a domestic household. For example, each of your rooms of your house is a parallel circuit. So you can turn on the light in your bathroom and it doesn't turn on the light in your bedroom, possibly. And the reason for it is because each of your components has its own circuit. So basically we can define a parallel circuit as being a circuit with a number of branches. So I'll give you an example of what that would look like. So we've got our power supply here, and we've got a globe on this part of the circuit, and we've got another globe on this part of the circuit. So we can put a switch here, for example, and turn this off, but this one is still on. Or we could put a switch here as well and, you know, really control that. So it's far easier to control different parts of the circuit. Another thing is that you don't get that same drop of voltage. So if we've got 6 volts running through this circuit, well, 6 volts are going to go along this way and 6 volts are going to go along here as well. So on our series circuit, we had the same current, but the voltage was split between the different components. Whereas in a parallel circuit, we have the same voltage, but we split the current.